You've probably heard people argue about what breaks a fast and what doesn't. One person says black coffee is fine. Another says even a single calorie ruins everything. Someone swears by adding MCT oil to their morning drink, while purists insist on water only. The confusion is real. And honestly, it's frustrating. You search online for a simple answer and end up more confused than before. Every expert seems to have a different opinion. Some say fasting must be absolutely strict to work. Others say a little flexibility is perfectly fine. Who's right? But here's what most people miss. Your body doesn't have one fasting switch that's either on or off. It has multiple biological systems, and each one responds differently to what you consume. This is why the debate never seems to get resolved. People are arguing about different things without realizing it. Today, we're going to clear up the confusion between strict fasting and flexible fasting. Not by telling you which one is right or wrong, but by explaining what actually happens inside your body with each approach. Once you understand the science, you can make your own informed choice based on your personal goals. Before we dive in, this is educational content, not medical advice. If you have any health conditions, please consult your doctor before changing your eating patterns. Now let's start with the basics. When you stop eating, your body doesn't immediately enter a fasting state. For the first several hours, it simply uses the energy from your last meal. Your digestive system is still processing what you ate. Nutrients are still being absorbed into your bloodstream. Your body is in what scientists call the fed state. The real shift happens later, typically around the 12-hour mark, when something important occurs in your liver. Your liver stores a form of sugar called glycogen. This is your body's short-term energy reserve glucose packed away for easy access between meals. When you eat regularly throughout the day, this reserve stays topped up. Your body always has quick fuel available, but when you stop eating for an extended period, this reserve gradually empties. Your liver can only hold so much glycogen, roughly enough to last 12 to 24 hours, depending on your activity level and body size. Once your liver glycogen runs low, your body faces a choice. It needs energy to keep your heart beating, your brain thinking, your cells functioning. But glucose from food isn't coming, so it switches to an alternative fuel source, your stored body fat. This transition point is often called the metabolic switch. It's the moment when your body shifts from burning sugar to burning fat for fuel. Your metabolism fundamentally changes direction. And this is where the real benefits of fasting begin. This metabolic switch isn't a modern invention or a diet trend. It's an ancient survival mechanism. For most of human history, our ancestors didn't have access to food around the clock. They experienced natural cycles of eating and fasting. Their bodies evolved to handle both states, efficiently switching between fuel sources as needed. Here's the important thing to understand. Both strict fasting and flexible fasting can trigger this metabolic switch. The difference lies in how each approach affects the various biological systems in your body. And this brings us to a key concept that changes everything. Your body doesn't have just one response to fasting. It has four distinct biological axes, four separate systems that each react differently to what you consume. Understanding these four axes is the key to understanding the strict versus flexible fasting debate. Let me walk you through each one. The first axis is insulin. Insulin is a hormone produced by your pancreas. When you eat especially carbohydrates and protein, your pancreas releases insulin into your bloodstream. Insulin's job is to help cells absorb glucose for energy and to signal your body to store excess energy as fat. Here's why this matters for fasting. When insulin levels are high, your body is in storage mode. Fat stays locked inside your fat cells. But when insulin levels drop, the opposite happens. Your body shifts into release mode, and fat becomes available to be burned for energy. During strict fasting, where you consume only water, insulin drops to its lowest possible level. Nothing is stimulating your pancreas to release insulin. During flexible fasting, the effect depends entirely on what you consume. Pure fats like MCT oil or coconut oil cause very minimal insulin response. Your pancreas barely reacts to them. But protein triggers a moderate insulin response. And carbohydrates, even small amounts, cause a significant insulin spike. So if your primary goal is fat loss, keeping insulin low matters. Strict fasting achieves this completely. Flexible fasting with pure fats still keeps insulin very low. But flexible fasting with protein or carbs will raise insulin and slow down fat release. The second axis is autophagy. Autophagy is a process where your cells break down and recycle their own damaged components. The word literally means self-eating in Greek, but it's actually a beneficial process. It's your body's internal cleanup and recycling system. Every day, your cells accumulate damaged proteins, malfunctioning mitochondria, and other cellular debris. When autophagy is active, your cells identify this damage, break it down into basic components, and reuse those components to build new, healthy structures. It's like having a cleanup crew that also recycles the trash into building materials. In 2023, researchers at the University of Adelaide and the South Australian Health and Medical Research Institute published results from a randomized controlled trial in Nature Medicine. The study followed 121 adults over 6 months and found that those practicing intermittent fasting showed increased autophagy activity compared to those following standard dietary advice. What made this study significant was that researchers had developed a new blood test to actually measure autophagy in living humans, something that had been extremely difficult to do before. This allowed them to demonstrate for the first time what had only been shown in animal studies for decades. Autophagy is activated when a cellular sensor called mTOR is suppressed. mTOR stands for mechanistic target of rapamycin, but you don't need to remember that technical name. Just understand that mTOR is like a construction signal inside your cells. When nutrients are abundant, especially protein and amino acids, mTOR is active and tells cells to build and grow. When nutrients are scarce, mTOR quiets down and cells shift into cleanup mode instead of growth mode. This makes biological sense. When food is plentiful, your body prioritizes growth and building. When food is scarce, your body prioritizes maintenance and repair. Autophagy is the repair mechanism. During strict fasting, mTOR stays suppressed and autophagy runs at full capacity. Your cells are actively cleaning house, recycling old components, and maintaining their health. Now here's something interesting about coffee. A 2014 study published in Cell Cycle found that coffee, both caffeinated and decaffeinated, triggers autophagy in mice. The researchers discovered that polyphenols in coffee, not caffeine, were responsible for this effect. The coffee actually enhanced the cellular cleanup process rather than stopping it. This means black coffee during fasting may actually support autophagy rather than disrupt it. However, protein and amino acids tell a different story. Even small amounts of protein activate mTOR, which suppresses autophagy. So if maximizing cellular cleanup is your goal, strict fasting or black coffee only would be your best approach. Adding protein powder or bone broth would work against this specific benefit. The third axis is ketone production. When your body burns fat for fuel, your liver produces molecules called ketones. There are three main types, but the most important one for energy is called beta hydroxybutyrate. Ketones are special because they can cross the blood-brain barrier and directly fuel your brain cells. This is crucial to understand. Your brain is extremely energy hungry. It accounts for only about 2% of your body weight, but uses roughly 20% of your daily energy. And unlike your muscles, which can burn fat directly, your brain cannot use fat as fuel. It needs either glucose or ketones. Normally, your brain runs primarily on glucose from the food you eat. But when glucose becomes scarce during fasting, your liver ramps up ketone production to keep your brain functioning. Ketones become an alternative fuel source that keeps you mentally sharp, even when you haven't eaten. Many people describe the ketone-fueled state as mental clarity. They report a feeling of sharp focus, steady concentration, and absence of the mental fog that sometimes comes after meals. There are no energy crashes or afternoon slumps. The energy feels clean and consistent. This isn't just subjective experience. Research suggests that ketones provide a more efficient and stable energy source for brain cells compared to glucose. Your brain doesn't experience the same fluctuations it gets from blood sugar spikes and drops. Here's where flexible fasting gets interesting. MCT oil, which stands for medium-chain triglycerides, is a type of fat that your liver converts into ketones very rapidly. Unlike long-chain fats that require multiple steps to process, medium-chain fats go almost directly to your liver and get converted to ketones quickly. When you consume MCT oil during a fast, something counterintuitive happens. Even though you're adding calories, you're actually accelerating ketone production. You're giving your liver extra raw material to make brain fuel. This means flexible fasting with MCT oil can give you more ketones, more mental energy, and more focus than strict fasting alone, at least in the short term. Your body is still burning fat. Your insulin stays low. But now you have an extra boost of brain fuel. For strict fasting, ketones rise naturally as your body taps into its own fat stores. For flexible fasting with MCT oil, ketones rise faster and higher because you're adding extra raw material for ketone production. The fourth axis is your digestive system and nervous system. When you stop eating, your digestive system gets a rest. Digestive enzymes don't need to be produced. Your stomach and intestines aren't working to break down food. Your gut lining has time to repair and regenerate. There's also something called the cephalic phase response. This is your body's reaction to tasting something even before any nutrients enter your system. When you taste something sweet, your brain sends a signal to your pancreas saying food is coming, get ready. Your pancreas may start releasing small amounts of insulin in anticipation. This is why artificial sweeteners are controversial in the fasting community. They have 0 calories, but they trigger the taste of sweetness. Some people's bodies respond by releasing insulin. Others don't respond at all. Research shows this varies significantly from person to person. In one study, only about 4 out of 7 participants showed an insulin response to artificial sweeteners. But there's another concern with artificial sweeteners that goes beyond insulin. A 2014 study published in the journal Nature found that saccharin, a common artificial sweetener, altered the gut bacteria in mice in ways that led to glucose intolerance. When researchers transplanted gut bacteria from mice that consumed saccharin into healthy mice, those healthy mice also developed glucose problems. This suggests that artificial sweeteners may affect your gut microbiome in ways we don't fully understand yet, even though they contain no calories. For strict fasting, your digestive system rests completely. For flexible fasting with black coffee or pure fats, digestive activity is minimal. But flexible fasting with artificial sweeteners may have effects on your gut bacteria that are still being researched. Now that you understand the four axes, let's address an important distinction that many people get wrong. Flexible fasting is not the same as low-calorie dieting. This confusion causes a lot of problems. Let me explain the difference clearly. When you eat a low-calorie diet, say 500 calories from mixed foods, including carbs, protein, and fat, your body enters what scientists call the fed state. Insulin is released. mTOR is activated. Your digestive system is fully engaged. Autophagy is suppressed. Your body is processing food, not fasting. When you do flexible fasting with, say, 50 calories from MCT oil or black coffee, your body stays in the fasted state. Insulin remains low. mTOR stays suppressed. Autophagy continues. Your metabolic switch stays flipped toward fat burning. The key insight is this: it's not the number of calories that determines whether you're fasting. It's the type of calories and the physiological response they trigger. 50 calories from MCT oil keeps you in a fasted state. 50 calories from bread pulls you out of it completely. This is why the strict versus flexible debate isn't really about being strict or lenient. It's about understanding which inputs affect which biological systems. Now let's talk about something that might be the most important part of this entire discussion. Many people become obsessed with perfect fasting. They stress over every small thing. Did that black coffee break my fast? Did that splash of cream ruin everything? Should I start over? This perfectionist mindset often backfires. The stress of trying to be perfect can be worse than the minor deviation itself. And when people feel they've failed, they often give up entirely. Here's the scientific reality. Your four biological axes don't all reset at once from a small disruption. A sip of coffee doesn't suddenly reverse hours of autophagy. A tiny amount of cream doesn't instantly refill your liver glycogen. Your body is more resilient and adaptable than that. The real mistake isn't being flexible instead of strict. The real mistake is not understanding the mechanisms and thinking that any small disturbance destroys everything. Fasting is not a moral test. It's not about willpower or perfection. It's about understanding your biology and making informed choices. So how do you choose between strict and flexible fasting? It depends on your primary goal. If your main goal is maximizing autophagy for cellular repair and longevity benefits, strict fasting or fasting with only black coffee or plain tea would be your best approach. Keep protein and amino acids out completely during your fasting window. If your main goal is fat loss, flexible fasting with pure fats like MCT oil or coconut oil still works well. Your insulin stays low, your body keeps burning fat, and you may find it easier to sustain over time. If your main goal is mental energy and focus, flexible fasting with coffee plus MCT oil might actually work better than strict fasting. You get enhanced ketone production and steady mental fuel throughout your fasting period, tu hua cafe. If your main goal is gut health and digestive rest, avoid artificial sweeteners, even though they have no calories. Stick with water, plain tea, or black coffee. And here's something important to remember. Your goals might change over time. Your approach can change too. Some days you might fast strictly. Other days you might be more flexible. Both approaches have value when used intentionally. Before we wrap up, a few important safety notes. Fasting, whether strict or flexible, is not appropriate for everyone. Pregnant women, breastfeeding mothers, people with a history of eating disorders, those who are underweight, and people with certain medical conditions should not fast without medical supervision. If you experience severe dizziness that doesn't improve with hydration, heart palpitations, confusion, or extreme weakness lasting more than 30 minutes, stop fasting and consult a healthcare professional. Listen to your body. Don't push through warning signs. So, what's the bottom line? Strict fasting and flexible fasting are not enemies. They're different tools for different purposes. Neither one is inherently better or worse. The question isn't which one is right. The question is which one is right for your specific goals, your lifestyle, and your body at this point in your life. When someone asks you, does this break a fast now? You know the better question to ask. Break which part of the fast? Which biological axis are we talking about? What is the person actually trying to achieve? A splash of MCT oil might enhance one aspect of fasting while technically adding calories. Black coffee might support autophagy while containing almost nothing. An artificial sweetener might have 0 calories but could affect your gut bacteria. Context matters. Goals matter. Understanding matters. The four axes: insulin, autophagy, ketones, and your digestive system give you the knowledge to make your own informed decisions. No more confusion. No more guilt. No more all or nothing thinking that leads to giving up entirely when you're not perfect. Fasting isn't about perfection. It's about understanding. Your body has been fasting and feeding for as long as humans have existed. These mechanisms are deeply embedded in your biology. They're robust, they're adaptable. They don't break from small variations. They respond predictably when you understand how they work. Now I'm curious about you. After everything you've learned today, which approach makes more sense for your goals? Are you team strict or team flexible? And more importantly, what are you fasting for? Drop your answer in the comments. Tell me your primary fasting goal, whether it's fat loss, longevity, mental clarity, or gut health. I read every comment and I genuinely want to know what this community is working toward. If this video helped you understand your body better, hit that subscribe button so you don't miss the next one. We have a lot more science to explore together. Until next time, keep learning, keep experimenting, and most importantly, keep listening to your body.